Before we enter the next phase for our developments, I would like to show you two common data structures that you're going to use a lot: arrays and linked lists. So now let's set up the testing classes for that. So click on the tests cluster here, and then click on new class, and then let's create a new class called test library. And then say creates. Okay, and every test class should be a subclass of ESTest. And then we're going to have a constructor make, and then we're going to put all the test cases under that. Okay, that's just to declare. And then we should have one section there for constructor. Okay, let me maximize it. Yeah, all the tests will actually come here later. And also, let's have one section for creating tests for Boolean queries. Okay, so that's about this particular test. Let's also go to our root class to add that particular test class. So all the test cases there will be included for execution. Let's just add it right before the previous one. So we'll say add control space for code completion, add test. And now we create anonymous objects for that particular test class. So we say create, over here curly brackets, test library dot make. And then let's compile. So everything compiles, so it's being set up. So now we can create a new test. Let's begin with a test for array. Test arrays. And that should be a Boolean query because we don't expect any violation to occur. So we don't do any test command. Do over here, and then always put the comments. Okay, let's simply copy that name over here, colon, and give some comments. You can say test basic operations of arrays. Okay, so now we can start building our tests. But before we forget, let's also include this particular Boolean test query into for execution. So we're going to say add Boolean case agents, the name of the class, the name of the test feature, test arrays. Okay, just to make sure everything compiles. So whatever we put in as update for test arrays, it will be included in the test report in the HTML. Let's first of all start declaring array objects over here. Let's say local variable. I'm going to need two arrays. So let me just call it S1 and S2. S stands for structure. So later on, we're going to use the same name for also linked list. So they are both linear structures. So structure 1, structure 2, now is of type array. Each member is going to be, let's just make it easy, a string. So string is a reference type. So whatever I'm demonstrating over here should be applicable to any reference member or integer or primitive member. For example, it can be array of birthday or array of integer. And then I will also need a loop counter later. So I'll just say I of type integer. Okay, we'll use them all later. So before I start coding, I would just like to show you where you can find a complete list of features for arrays and linked lists from iPhone Studio. So open a new tab over here and then simply type array. And then you can also type linked lists similarly. And then let me just double click on the tab. You can see from the features, you may just want to recompile first, otherwise it wouldn't show. Compile, and then you can see on the features panel over here, you can see all the features exhaustively, all the features for the arrays, and do the same exploration for linked lists. The ones I'm showing you are the most commonly used ones. Okay, let me close that, and let me switch to my iPad, and then I'll talk about the common features together with you. So the features I would like to go over are, first of all, let's start with creating an empty array. That's also a constructor. So as soon as you create an empty array by default, the lowest index would be 1 as opposed to 0. Okay, so now you can assume always the indices of an array start with 1. And then so lower would be the lowest index, and upper depends on the size of the array. For example, here you can see the indices will be 1, 2, and 3. And you can see that there's a formula over here. You might be interested. So what will be, okay, count will be the size of the array, in this case 3. So what's the relationship between count and also lower and upper? Okay, so count is always the same as upper minus lower plus 1. If you really like, you can actually rebase the indices into the lowest index being 0, but by default it's simply just 1. So that's the formula over here, just for your interest. For example, you can see 3 minus 1 plus 1 over here, it will be 3. So that's the size of the array. And then we also got valid index query over here. So the valid indices will be 1, 2, or 3. And also whether the array is empty. And item and indexing here are essentially doing the same thing. So if I say a.item, I need to pass a valid index. So if I say 2, and it is going to return back to me this particular item over here. And if I say 8 at index, for example, 3, like this Java or C notation, it's going to return back to me this particular element here. Okay, so very straightforward features over here. And then we're going to see how we can apply them to the code. Okay, so let's go to the code. Let's start by creating an empty array. So we can say create, using the create keyword instruction, s1.makeEmpty. MakeEmpty is a constructor. And now let's do some Boolean tests over here. I can say result is going to be assigned to the following conjuncts. First of all, let me remind you the size of the array is simply upper minus lower plus 1. And let me maximize the class for you. Okay. And then we'll say, for example, s1.lower is simply equal to 1. As I said before, by default, after creating empty, the indices will be starting from 1. And then s1.upper, because initially the size is simply just empty, so upper will just be 0. Okay, so 0 minus 1 plus 1 will give you 0. Okay, that's apply the formula. And s1.count, the size will just be 0. And also s1.isEmpty, which is a Boolean, should be returning to you true. Okay, and then let's do a couple of more. What about valid indices? Apparently s1 valid index at the moment is not going to return true to any index. For example, 0 is always an invalid index, so we can just put a negation over here, so it'll be not false. And also, because the array is empty, so we can also say not the case that s1 valid index, so 1 is also not a valid index in the beginning. Okay, so because we're gonna have multiple Boolean cases to test, so let's always put check result n over here, just make sure we don't miss it. Okay, so it's always important to make sure everything compiles, and then we're going to run the workbench system to make sure we get a green bar as always. Okay, that's good. So now we'll go back to the code and then we'll continue with our developments. And let's start by inserting some elements into the array. And the command we're going to use is force. So s1.force. And there are two arguments needed. The first argument is the new elements, in this case, a string. So let's say Alan. And then the second argument would be, at what index do you want to insert new elements? And typically, we want to make the force work like inserting to the last. So it's going to be, think about currently the array is simply just empty. And then we want to insert into index 1, exactly 1 more than the current size. So we'll say s1.count plus 1. Okay, let me write another 2, and then I'll visualize exactly how this is working. So we got s1.force, and let's have the second name, Mark. And I'm not changing the index expression over here. So dynamically, s1.count here is 0, and s1.count over here after the first insertion will be 1, and etc. Okay, so here we say Alan, Mark, and Tom. Okay, so now after inserting these 3 elements, let's see exactly how that would look like visually. Okay, so now let's take a look. As I said before, after calling makeEmpty over here, so the array is going to be of size 0, and then the lower should be 1 and the upper should be 0. Okay, so now think about, now s1 is now pointing to an array of size 0, is empty, and then the lower is simply just 1 by default, and also the upper is actually 0 by default, right? So 0 minus 1 plus 1 will be the size, which is 0. Okay, and now for the first one here, we simply say s1.force, and then we say Alan, and then s1.count plus 1. At this point, s1.count is simply just 0 plus 1. That means we're going to insert into index 1. So index 1 is over here, and then we want to insert Alan. So after this, lower stays to be 1, and then upper now becomes 1. Okay, so now 1 minus 1 plus 1, you get size 1. Okay, so hopefully you see that. Let me just do one more. And then the second one, we say S1 the force, and then we say mark. And then we still say S1 the count plus 1. So now at this point here, S1 the count has become already 1. So 1 plus 1 here will be 2. So that means at index 2, we're going to insert mark. And then after this second insertion, lower still remain to be 1, okay? And then upper has now become 2. So now if you think about the size, 2 minus 1, upper minus lower plus 1. So you actually get the size 2, okay? So that's why you get 1 element and 2 elements here, and so on. So I would say this particular pattern over here, simply the index for the force will just be whatever the size of the array currently it is, plus 1. So that's how we can make sure you always got a default indices starting from 1, and then grows like this. Okay, so that's about using the force. It might be the most unfamiliar command that you want to learn. Okay, so that's about the force, and then after this, let's do a few checks over here. So after this particular setup, we know we would have got an array of size 3. So I would say result is assigned to here, and then S1 the lower is simply 1, okay, always 1, and then S1 the upper equals 3, and S1 the count should be 3 elements 3, and currently the array is simply not empty, right? So not the case that S1 dot is empty. So it's as if we said S1 dot is empty equals false. Okay, so these are easy, and let's do another one. So what about indices? So it is not the case that S1 dot valid index 0. So 0 is always not valid. But what would be valid right now? So 1, 2, and 3 should be valid, right? Because we got 3 elements. So S1 dot valid index over here should be 1. Let me just copy that. So now 1, 2, and 3. 1, 2, and 3. So they are all valid. Okay, finally, how do we use the indexing notation, right? You can also say S1 the item and then pass 1. That's fine too. But the most common way to say is S1 at index 1 would be len. And notice I'm using tilde here as we explained previously. So tilde is going to call the isEqual query in the string class, right? It's about object equality. So len here, and then we say end S1 at position 2 is object equal to mark, and also S1 at position 3 object equal to pong. And we're gonna continue with more. So let's just say check result in. Okay, that's our second section here, and then let's make sure everything compile. And then let's run the workbench system to make sure everything's okay. Okay, so everything still pass. So you can see that's our test over here. So we'll keep building. And then the next one here, the next section there, we'll start to see another important attributes. And let's take a look at this attribute here, first of all, from the array class. Okay, if you create an empty tab here and simply type array. And I want you to type in the feature text field here called object comparison, object underscore comparison. So every collection class in IFO-based library, including array, linked lists, and also hash table, for example, these are the most commonly used 3 classes. They have an attribute here called object comparison. So object comparison here basically means it's a Boolean flag indicating if you want to query about a membership in this particular collection, are you going to check by reference equality or by object equality? I'm going to illustrate to you in just a moment. Okay, so just remember that every collection class you will use from the IFO base, they have this object comparison of Boolean attributes. But how can you change its value? Okay, I want to show you another one. I'll show you how to use it. It's called compare objects. Compare object is going to set the Boolean flag object comparison from false to true. Okay, that's something you can also use. I'll illustrate to you. And it's just for it's not just for array. For example, if you also go to linked list, they also get this particular object comparison attributes over here. Okay, so every collection class will actually got these particular attributes. Okay, let me close it and let me come back here, and then let's just do some basic check. So I will start by checking to see what's the default value for object comparison. So I would say result is assigned to and then I would say s1 dot object comparison. We haven't changed that just yet, so it will just remain to be the default. So it's equal to false, and we might turn it to be true later if necessary. And we'll say s1 dot has, we are inquiring about the membership of this particular string, let's say Alan. So you would think intuitively Alan is at the first position here, so has should be true. And then we'll say s1 dot occurrences over here, and then so we're asking how many times does this particular string, let's say Alan again, happen in the array. And now Alan seems to be only occurring just once over here, right? So we'll say equals 1. And then we'll we might have more tests to actually write. So we'll say check result end. Okay, so let's compile and then run it. That's our intuition. Let's see if that's really the case. And then I'll say run, and then run workbench system. And unfortunately, we do have a check assertion violated, and more specifically, it's the last check assertion we introduced. That's why you can see test-driven development really works. Every time once we have written a particular block of test cases, you want to run workbench system right away. So you will see as soon as you got some red bar. Okay, let me return back to the code and then maximize it. So what's happening here is, by default, s1.object comparison is simply false. So that means what you're really doing over here is you're asking if there is any member in the array that has the same address as this particular string. But this string here, argument string, was simply created on the fly. So it's actually a separate string object. So there's no such string in the array that has the same address. So that's why this should be false, because now we are only comparing by references, because object comparison is actually false. Let's say for occurrences, it will be the same idea. There's no such string with the same address as Alan, so the occurrences should be 0. Let's compile, and then let's run the workbench system again. So now we get a green bar, okay? So the good follow-up question will be, how can we actually turn the flag over here from false to true? Well, that's something I just showed you before. You can simply say, let's say s1.compare objects. So that means from now on, we actually want to compare, and whenever we inquire about a membership about the array, we want to compare that against the argument string using is equal, which means the contents, the is equal query of the string class. And of course, if you have an array of birthday objects, in that case, once you say the array that compare objects, you will compare using the is equal query that's redefined in the birthday class, which we did previously. Okay, so now after this, we would expect S1, the object comparison, to be true. So let me just copy the same block, very similar structure. So now this should be true, and now S1 that has Alan should be true, because now by object contents is now Alan should be there, right? Even though they are different strings by addresses. And now this should be 1. And one very quick remark. So what if later I want to switch back to compare references? So there is another command over here. Let me just show you very quickly for completeness. If you go to array class, and then you also got another one command called compare references. So that's how you turn the flag from true to false. Okay, so now let's compile, and then let's run the workbench system again. Okay, so everything works. So please make sure you really understand the important role that this particular attribute is playing whenever you're inquiring about a membership of the array. So the next feature of the array or collection I'd like to show you is how you can run a loop for the array, which is very conceptually equivalent to running a for loop or while loop, like in Java or the C family language. But let's see what the difference is. There are two ways to run a loop in IFO. I'll just show you the first one. The other one is by using the cross keyword, which I will cover in a later video. Okay, so now what we would like to do is, remember there was a second local variable called S2 over here. So let's say we want to do the following. We have already built S1 being an array of having 3 elements. So let's say we want to copy the elements one by one from S1 to S2. Then we want to see how we can use a loop to do it. Okay. So I want you to try the following. type from over here and then hit enter. So you can see the code completion for ifo compiler will give you this skeleton over here. So from, until, and loop. So these are the three parts we have to fill in. Let me do one by one. And also be reminded that we also declare a local variable I for loop counter. Okay, so let's do something very similar to like a for loop or while loop. We have to first initialize the loop counter. So we're going to say I is assigned to 1. And so here we are assuming that S1 the lower is simply just 1. Okay, or you can say I is assigned to S1 the lower. That's also fine. Okay, so now the until part is the opposite to what you're used to for the while loop. Let me say that. You're saying that we are going to execute the body of the loop until this particular condition is actually true. So it's more like an exit condition. It's the opposite to what you're used to in the while loop. For example, in the while loop, you're saying as long as certain condition is actually satisfied, I'm going to stay in the loop. It's a stay condition. So exit versus stay condition. Let me write it down and I'll make some notes for you. So let's say we're going to stay until I is no longer a valid index. It's way too large because we keep incrementing it. So S1.count is strictly larger, right? S1.count will still be okay, but S1.count plus 1 will start to be invalid. So this is so-called exit condition. Okay, let me just make more notes over here for you. It's actually equivalent to the stay condition that you're very used to in the C family language. For example, if you say while initialize actually for loop. Let's say you have a for loop, you have some initialization here, and then also this will be the increment part, which we'll do in a moment, and this will be a state condition. We're saying as long as I is still valid. So you say as long as S1.count is actually larger than or equal to I. And notice that this condition over here is exactly the logical negation of this one here. We are simply changing from larger than into less than or equal to. Again, it's a design choice the ifo language designer makes. You just have to know whenever you specify until, think about it's more like an exit condition. Until when do I actually have to stop executing the body implementation of the loop? Okay, so now how do we copy? So we're going to use the force that we just learned, but now we do not have any specific index anymore, so it has to be general. But you know the way we put it before is actually general enough. So we say s2.force over here. So now, first of all, let me get to the, we want to copy the elements one by one. So S1 at position the loop counter, and then it should be whatever the current size is plus 1. So it would be in the very first iteration when S2 is actually empty. So we say S2.count plus 1. So think about the first iteration. For the very first iteration, S2.count is simply 0. 0 plus 1 will give you 1. So that means we're inserting at position 1. For the second iteration, S2.count will be 1. 1 plus 1 will be 2. So we're inserting into index 2 and etc. And the most common mistake of having a loop over here is you forgot to actually increment the I, in which case you will get an infinite loop, right? So I is assigned to I plus 1. Please make sure it's a very simple but very common mistake. Okay, so after this, we would like to check to see whether S2 has been set up properly. So I would like to just go back a little bit, and then I would like to simply use this block of code over here that we used to check for S1. I'm just going to replace systematically from S1 to S2. Okay, so now S2, the lower should be 1. S2, the upper also should be 3, right? Because we use the make empty over here. Did I say make empty here? Okay, we haven't. Okay, I will illustrate something to you in just a moment. Okay, notice that we went to write the loop directly, right? But now, so far, S2 has not even been initialized. Agree? Okay, let's haven't hit the compiled yet. That's why I didn't know there's such a mistake. But I will tell you why. S2 and then S2 over here, and also S2 and also S2 and also S2 and also S2, and then okay, just a little bit more S2. S2 and S2. Okay, so now if we hit the compile, let's see what's going to happen. If I say compile over here, so now I'm having something called target of the object called might be void. Remember I said before void is like a null pointer, right? So that the compiler is warning us we might have null pointer exception, but where? If I double click on this, you can see it's complaining that over here, you're saying S2.force. However, the target S2 might be void. So this is something related to voice safety, which I'll address a little bit later in the video and also in the lecture. But S2 simply is telling you that S2 may not have been initialized yet. That's actually true because S2 was declared over here. However, from there until the first time S2 is used, I never said create S2.makeEmpty. I never said that. So S2 might be void. So if you expand the error messages over here, it's telling you exactly that. The target of the object call might be void. What do you have to do? You have to make sure you at least initialize it before you use it. Okay, it's a very good mechanism by the compiler to make sure you don't have any null pointer exception at the runtime. Okay, and now what I should do is, well, of course, I just forgot to do, but it's very important to make sure you always initialize reference type attributes. So I would say creates s2.makeEmpty over here. Okay, and then I'll say compile. So now everything's good, and then I'm going to run the workbench system. Okay, everything still works. Okay, let me just do one more thing for us. Okay, let me hit the enter over here, and then the final thing I would like to do is to compare S1 and S2. Okay, you can see now S1 has 3 elements, Alan, Mark, and Tom. Also, S2 is simply just a copy. Well, just by using reference copy, because we are simply just use over here just a force. So it's not creating any new objects. Okay, so now if I say the following, okay, it should be very comfortable by saying, if I say result is S1 equals S2, are these 2 arrays having the same starting addresses? The answer should be no, because they were created using actually different create instructions, right? So now if I say that, that will say, let me just say that, okay? And then if I simply try to run the workbench system, it's going to give me a red bar, right? That's kind of expected because S1 and S2, they're different array objects. So what I should do is I should say they are different objects, so not equal to. Okay, that's the first one I would like to double check with you. It's kind of corresponding to the previous video that we talk about reference versus object equality. Okay, let me do another one. How do we compare contents? Remember I said either you can say s1 dot is underscore equal s2, or you can use tilde. So now I'm simply going to use tilde. The result is s1 tilde s2, right? You would think these 2 arrays should be content equal because it's also Alan, Mark, and Tom, right? For both arrays, you would think. So let's try. Compile, and then I would say run, and run workbench system, but it's not really working over here. So what we would like to find out, which I would like to show you, is how exactly is the is equal for the array actually works. I can tell you, I can give you a little bit hints. It has to do with object comparison. Okay. So now what I would like to do now is let's set a breakpoint, right? Remember we said about how you can do it. Let me do, just simply make sure you click on the feature tag over here at the bottom. Highlight the feature, right click to drag, and right click to drop. And then we're just going to look at the final line over here. Let's set a breakpoint right before we execute it, and we're going to step into that particular routine call. So I would say run over here. And then so now I'm pausing over here exactly right before I call the tilde operation. And then I want to step into. So presumably I should really expect to see the is equal feature for the array class. So now I'll say step into. So now exactly you can see now the current class is array. I'm looking at the is equal feature, right? It's quite a little bit long routine, but I just want to point to you exactly what I want you to look at. You can see in order to actually check the equality between 2 arrays, first of all, they simply compare reference, right? If their reference equal, of course, their content equal. And also otherwise, so else if is something, you know, just something else. Otherwise, they're actually going to actually look at over here, whether the object comparison attributes for the 2 array the 2 array objects are equal. If they are not, they are just not equal. So remember, so okay, that's what I want to show you. Let me pause over here. Okay, let me go back. Okay, let me maximize it. Remember what we did before. We said s1.compare objects. So that means s1.object comparison has been switched from false to true. Whereas for S2, after we have created it, the object comparison for that actually remains to be actually false. So we got S1 the object comparison and S2 the object comparison. They are not the same. One is true, the other one is false. So now, even though we think they're content equal, but they are really not. So you always have to be careful. When you want to compare 2 IFO-based collection, make sure not only that their contents are the same, but also you want to make sure their object comparison attributes is also consistent. You can also refer to the study notes, the written notes that I provided to you. I also wrote it down in a little bit more details over there. Okay, so the way to really do it is, let's first of all to say at the moment they are not the same. Okay, so now what I just say s1 dot object comparison is true, but s2 dot object comparison is false. Okay, check result in. Okay, so that one is going to be fine. So now, in order to really make sure they are really the same, so you want to make sure the object comparison value is consistent. So I would say s2 dot compare objects. So that will switch its flag from false to true. After this, I can say result is assigned to s1 tilde s2. So this time, hopefully that's going to be fine. So let me compile, and then I will run the workbench system here. Okay, so everything works. Okay, so that's about the common features I would like to show you for the array. In the next video, I'm going to show you exactly the same common ones for linked lists.